I'm Jeremy Rausch. With me I have Dave Goldsmith. We're from a company called Matisano, small boutique combination consulting product company out of New York and Chicago, specializing in pretty much everything security-wise, a little bit of everything.
Security.
Application security. In particular, the New York folks, myself and Dave and a few others, have a particular interest in financial protocols. So we're going to talk real quickly, both in the rate we're going to speak and the amount of stuff we're going to cover, real quickly about looking at a small subset of some of the financial protocols we've looked at, some of the lessons we've learned, and hopefully give everybody who's here a little bit of insight as to how you go about testing one of these specialized protocols.
Right, and we consider this this is a starting point, right? I think when we first started working in, and Jeremy and I have actually both been kind of working on Wall Street before Matisano. Actually, Jeremy lived on Wall Street for a while, and you know, in over the past couple of years, we've managed to do a couple of assessments that involved looking at some of the protocols that investment banks, hedge funds, and places like NASDAQ and NYSE communicate with each other. So that, I think if anyone saw the description of the talk, you see that we're going to really be focusing a little bit on FIX for this talk. There is more to talk about. We've also talked to the folks at FIX Protocol, so this is not the kind of thing where we just we're up here and we haven't had any communication, and we'll pepper their comments as we understood them throughout this talk. When you think about the way that these companies communicate with each other, yeah, I mean, there's lots of web-based protocols, just like there would be anywhere else. But when it comes to transactions, they have to use things that are going to allow them to hit the performance requirements they have. You're not going to see as much HTTP, HTTPS for these types of applications. They also tend to be things that, for the most part, have been buried towards the backs of their networks, right? They're not the kind of things that are necessarily exposed on the internet for everyone, although we'll talk a little bit more about that. But as a result of this, they tend not to get tested as well as other parts of their environment. They tend to be the types of things where they say, well, we have mitigations in place to try and make sure that nobody gets access to these applications that shouldn't. They use some other techniques as well. And one of the things that we found is that we've had customers coming to us saying, well, you know what, actually it's time for us to kind of lift up this rock a little bit. Let's take a look at what's actually going on here and see if there aren't more security mechanisms that we can be looking at, and let's understand what's actually going on with these applications.
Sure, and I think one of the things that we discovered when we first began a few years ago looking at these protocols was that there's not a lot of knowledge in the security community about how these protocols are different than everything else we're used to testing, what kind of methodologies I need to follow, and what's been tested and what hasn't been tested. I think using something like Black Hat as an example, there's a lot of talks that cover a lot of interesting general purpose protocols and general purpose applications, but there's not a lot of attention being paid towards research into the flaws that can exist in the applications that implement these very specific, targeted protocols. Okay.
So when you think about priorities for how these applications work, I apologize, by the way, you're going to find that I'm one of those people whose voice changes, and at some point I'm going to talk really loud and I'll talk softer, so I apologize if I'm booming right now. When we started doing this type of assessment work, some of the first things that we noticed were pushback around what we would consider some basic security mechanisms, and there's good reasons for it. But when you look at the priorities of trading protocols, performance and availability become kind of really critical, the most important parts of this protocol, and the way that they communicate. And there's really good reason for this. Most of it has to do with the faster they can communicate, the more likely they can capitalize in certain situations. There's a direct translation to how much money is made based on how fast they can be communicated.
Right. When you're doing automated trading, things like looking at arbitrage as ways to make money, microseconds do count, right? So any kind of security that introduces increased latency is going to be frowned upon when it comes to these systems.
So as a result, some of the ways that security gets implemented currently is certainly, rely on insider trust. There's no doubt that you have to have some sense of trust in terms of saying, okay, these are people who are working on these systems. We have to let them work on these systems so that they work. There are firewalls in place. A lot of this traffic does go through private networks. This is partly security, and this partly gets back to performance, right? The internet is just not reliable enough. But obviously that there's some benefit by not having this traffic go over the internet. And then the final step in this is back-end processes when even if someone manages to perform a trade that wasn't authorized or do something they weren't supposed to do, there's a rely on the fact that during the clearing process it will hopefully be determined that something happened that they didn't want happening.
Sure. Okay, one of the things that you kind of discover when you go about evaluating these financial applications is that there's a real grab bag of protocols out there. From a security perspective, when we go and look at these protocols and begin to understand them and look at what people are using, from our perspective when we're doing testing, there's a lot of protocols that all seem to do the same thing, which isn't entirely true. They all have their specialized purposes, and talking in different markets or in different areas, you have a different set of protocols that you need to use. Point being, there are a lot of protocols out there that are being used in financial services and in banks that are probably not familiar to everybody here, and certainly not familiar to your average security tester type person, because they're very specific. Some of them are not fully described or spec'd out so that someone can go and look at them from a security perspective and determine what they need to test. Right. Just as an example, these are just a handful of ones off the NASDAQ specifications page. Every exchange has a different set of protocols they're using, different set of tools that have to be developed, or a different set of testing protocols that you need to employ in order to go about evaluating the security of those protocols.
You're right. And I mean, every time that we're asked to do an assessment that involves these types of protocols, we end up spending a lot of time digging through specifications, trying to figure out how the protocol works, writing our own clients. This is the type of work that we end up having to do just to even get started. And again, these are really just the ones that NASDAQ uses, and you'd have to, if you log into their site, they will give you more information about these protocols, but you do have to, accept some terms and conditions, which is one reason why they're not talked about here. That and we don't have the time. So we kind of hit on this earlier, right? When it comes to priorities, this is now getting into the security implications here. Being able to protect these applications from an availability perspective is critical, right? This is a little bit different from people that may have had to do testing of other types of applications. If something goes down here, it can be disastrous. It can be very expensive. Even just causing performance problems can be costly. When we first started looking at these applications, as a penetration tester, you're always thinking like, well, how am I going to get root, right? How am I going to break the system? How am I going to get administrative privileges, access to the database, whatever it is? And when we'd find an issue that was just purely availability related, it got people's attention. That had their eye faster sometimes than some of the confidentiality issues that we'd find. They were more concerned that this system stays up and running, which is, it makes sense, right? That is not a bad prioritization. It's just really different when you're coming at it from a vulnerability testing perspective.
Sure. A bad trade or an invalid trade will be caught. A server going down is costing money for every second that it's down.
Right. That's just kind of like how with this slide, we're just trying to say that the priorities are a little bit different.
So what we've decided to do, given our very small time frame, which we've said now 50 times, we're just going to be looking at the FIX protocol and applications built on top of FIX. Not because FIX is a particularly bad protocol, but because it actually happens to be one of the more transparent protocols. The specifications are publicly available. You can go to fixprotocol.org, and you can download the specifications and learn about them. So it's actually something that, as a security researcher, if any of you are in the security research or the evaluation side of things, you're actually able to go and, in the case of FIX, get full specifications, as well as actually download a free engine that you can play with. So it kind of gives you a natural way to actually look at some of these things if you're interested in them and begin to evaluate them. So just some quick FIX information, which is the name of the free client. Fix is a very broad protocol. There are a large quantity of messages available in the Fix protocol for conducting a variety of different types of transactions. It runs over TCP. It specifies both, at least in Fix 5.0, a session layer as well as an application layer. Right? The session layer guides how logins are established, how sessions are brought up and torn down, and how messages are exchanged, and an application protocol that specifies the different types of messages and transactions you can conduct. In terms of specifications, there's thousands of pages of documentation around these messages and how these messages are constructed. One of the things that is not well documented in Fix are security best practices. Right? Fix is just a specification. Right? In talking with the Fix protocol people, they're pretty forthright about that. Like we've laid out a protocol that's widely in use and documented it well so that people can interoperate and develop their own engines. And security is something that there are general well-known practices within the Fix community that aren't necessarily documented for the security folks or for people who are new to the whole system.
We're about halfway through, so we have to...
Yeah, I know. We're going to move. We're going to move. Fix protocol, real quickly. Here's a sample message. Fix messages are typically of the type equals value pairs, separated by a hex 1 byte. They can be a combination of type equals value pairs as well as something called FixML. Typically in Fix 4.4, which is the most common version, 4.4 and prior. Right? 5.0 has only been out since December, so it's not in widespread adoption. Typically, if you're using the Fix transport layer, you're using the type equals value pairs, and if you're using an alternate transport like MQ or the web or any kind of multicast protocol, you might be using the FixML. It's just typically how it breaks down in actual use. Types are numeric. So if you have a numeric value, it's actually an ASCII value. So everything is a string within the Fix protocol. Type equals value pairs themselves. 5.0, again, the current version, the 4.x versions are by far the most common. Sample packet. The slides will be up on the Black Hat site as well as our website, so you'll be able to take a look at that if you're interested.
And it's not generally responsive, by the way, just from from a just quick tactical, technology perspective. It can be on any port. When you find it, you won't necessarily know that you found it. Sometimes you can get it to respond by sending messages that are invalid login messages or whatnot, but a lot of times it won't. So when we're doing testing, it's rarely blind, right? They tell us the port that it's on. They say, this is where Fix is. Go look at it. So it's not the kind of thing that you're gonna find, or you're gonna see an Nmap option added to detect that this is actually a Fix application.
Okay, so let's say you're implementing a Fix fuzzer or some kind of tool for testing Fix, doing code coverage of a Fix application, right? Things you got to know. Fix standard header contains 6 fields that must be present. Those are the begin string, which is the version of Fix you're going to be establishing a session with. So Fix 4.4, 4.3, 4.1, whatever. Okay. A body length, which is the length of the whole message minus the begin string and the body length field itself. The message type, right? The type of message you're going to be sending. The sender comp ID, and this is an important field. The sender comp ID establishes who you are, right? Who am I speaking as at the institutional level? The target comp ID, which is who I'm speaking to, and a sequence number. The sequence numbers are used to guarantee delivery of Fix messages. While it's on top of TCP, because of the fact that while TCP is a reliable transport, there are conditions where you can't be 100% sure a given transactional packet was sent successfully. So it gives the two peers an opportunity to be able to sync up with each other to say, you know what, you think you're at sequence 35. I've never seen number 34. Please resend it. And every trailer has a checksum to detect single bit errors.
And then also, remember, transport independence in Fix 5 means that you have multicast UDP as well.
Sure.
So there are other protocols in play.
There are a number of standard admin messages. These are the ones that if you're going to be writing a Fix client for doing testing, you're going to have to know about and use to some degree in order to communicate and do stateful testing and do good code coverage testing. The really basic ones are there's a login and a logout. One of the things about the logon to recognize is that it uses optionally a username and password. And we'll touch upon that a little bit later down. They are optional, right? In the case of a logon message, one of the things that as a security person, you always kind of look at a little bit funny is that the encrypt method used, which is one of the type value pairs, by definition must be unencrypted. Now, that's kind of because there's a chicken and egg problem, right? If you want to use one of the built-in fix encryption protocols, you have to know what user you're dealing with. So the logon message itself, your username and password must be transmitted in clear text. We'll talk about why that's not necessarily such a big deal, hopefully in a second. But by definition, it's unencrypted.
Right. And also, by the way, the first time we did one of these assessments, one of the first things that we learned was that there wasn't any username or password. Right? It was like they gave it to us, and they said, "Here's everything you need to log in," and there was no password or anything like that. And they were like, "Okay, well that's interesting." And then the next one, they gave us a username and password, and it didn't work. I had to actually remove the username and password to log in. So there's always these like little bits of interesting details when you start doing this type of work.
Okay, the next slide just kind of illustrates there's two layers. There's the admin layer and there's the application layer. Admin layer is used for maintaining a session, logging in, logging out, things like that, heart beating. There's actually a whole layer of application messages, and there are hundreds and hundreds of application level messages, kind of covering every aspect you could have of a trade. Quotes, events. There's even a thing for email and notifications. Basically, a whole lot of messages. Lesson being, if you're doing testing on Fix and you're testing a generic engine, based on what the application is, there's a whole slew of messages it may handle, and you need to be able to test these messages and make sure that they're handled correctly at the application level.
And coverage is really challenging on this, not just from an implementation perspective, like looking for buffer overflows, format strings. By the way, SQL injection too, because a lot of times it gets back-ended to a database. So you get a little bit of everything in here from a pen testing perspective, but then you also have all the logic issues that you could run into inside of this. So it's a big surface area to try and attack and get comprehensive testing coverage on. Okay,
real quick, just a quick overview. Fix applications, right? You're dealing with very complex transactions and systems. They tend to have complex implementations. Right? You've got an engine layer, which is typically done by a third party, or let's say quick fix, if that's the way you go. And there's a whole application built on top of it. Fix itself is a way of communicating, and then those messages are parsed and then given to the application, who then handles them in another way, which may or may not be secure. One of the other things is Fix leaves a lot undefined. How you handle certain cases, and we have a kind of a laundry list of questions we ask whenever we evaluate these systems that really are dependent upon the engine, how you handle certain error conditions. Let's just go quick.
Sure. So, and on top of that, it's also important to note that this doesn't usually result in interoperability problems, the fact that there may be, gaps in the specification, but it leads to interesting security problems, and it certainly leads to interesting test conditions because people aren't doing a lot of negative testing, right? This is about making sure that everything works. When they talk to each other, are the messages getting through? Are they getting through in the right way? So there's a lot of interesting things that you can do there. When it comes to authentication, talked about a little bit, username and password based typically. On many systems, if there is a password set up, nobody's changing it. And then finally, it's pretty rare that people are using passwords. And again, when you talk to people about it, there are reasonable reasons for why they say that. What I find really interesting about assessing these types of applications is just the difference between where developers on it are on it with some of the security features compared to where security people think it should be. So that's really where it gets interesting, right? Fix people that build Fix applications will tend to say, well, this isn't a problem because it's a back-ended system. It's not going over the internet. All kinds of reasons for why. But then when the security people look at it, security people don't always agree with the application folk. So that's kind of one of the big challenges that we found when we were going through it, right? On one of our Fix assessments, they knew. The security guys knew about this, and they were just praying that we would notice it, right? Just please notice that passwords aren't changing.
Yeah, basically, I think the big punchline here is that a lot of times Fix security relies on the secrecy or the lack of desire on anyone's part to change their sender comp ID to what's probably a predictable value for a different financial institution and communicate with that.
And by the way, lots of times sender comp ID is institution name. So
yeah.
This is not the kind of thing where it's going to be just random string of letters and numbers. On a good chunk of systems, it is likely to be the name of the institution.
Sure. So one of the things,
we're
Fix,
done?
Can we keep on going if people want to stay? I have to get off the stage?
Yeah, there's another.
No, there isn't. There's a break right now.
There's a break, but we got to stop.
All right. Quick punchlines. One of the things you need to keep in mind is if you're using something like S-Tunnel or SSL in order to secure your Fix transactions, make sure you're looking at how you're binding your sender comp IDs to your certificates, because there's no causal binding between the two. So if I can connect with S-Tunnel using my cert and send another sender comp ID, SSL doesn't buy you a whole lot there.
Thanks for attending our talk. Sorry we didn't get through it all.
There'll be slides available online, and maybe we'll write something up someday.
Thank you.